Hello, so this is Warren from Apollo Tech Support again, and we're just going to have a look at the XP95 intrinsically safe equipment. So intrinsically safe equipment is devices that are used in hazardous areas, areas where you might have dangerous mixtures of gases and chemicals, and if you get a spark off the electrical equipment in that area, it could cause an explosion. So these devices are specially made and certified so that they don't spark or overheat in a hazardous area and obviously cause an explosion. So this is XP95 intrinsically safe. Essentially what you would have on an addressable circuit is a spur off of the loop or a radial off of the loop, which is made at a device called a protocol translator. So the protocol translator is the first device in the line here, and it's a device that translates standard loop protocol into intrinsically safe detection protocol and back again. It doesn't take an address, and all it's doing is translating the communications between one part of the circuit and the other. And that's because there's much lower power being used in the IS circuit, so therefore the protocol, communications protocol that we use on our normal addressable devices is kind of squashed, depowered, much lower, and that device allows that protocol to go through into the hazardous area and come back out again. So that's the first device in the circuit. We've basically got our loop tester attached, and our wiring goes into the protocol translator, and then protocol translator is connected to this device, which is a barrier. Barriers are basically devices that stop any large power being drawn into the hazardous area and make the wiring safe so that you can work on a live circuit without causing any sparks and obviously causing an explosion. So the blue end of the barrier is basically the IS going out into our devices. And these devices are typically going to be, so typically we would have 24 volts here at the loop side, and then by the time we get into the hazardous area we're down to about 16-17 volts on our circuit going out to our detection devices. There's a different barrier for every different type of device that you might use in the hazardous area, as far as IS devices are concerned, with Apollo devices anyway. So this barrier is a P&F barrier, and it's a KFDO CS EX 1.54 barrier, and it's the only barrier we know of that will allow our communications protocol to feed through into the hazardous area. There's a different barrier for the Orbis IS products, and then again there's another different barrier to use with sounders. With XP-IS you don't get any addressable sounders that you can use. It's purely detection devices. We do smoke detectors, we do heat detectors, and we do call points that you can use in the hazardous area on the detection circuit for XP-IS. If we have a look at the loop tester, we've got an analog value of 23 on our detector, and obviously if we had smoke added to the device, so we just had a bit of smoke, you can see that analog value rise up very quickly just from a minimal amount of smoke. It's going to drop down now, so it's no longer seeing smoke. Give it a bit of a blow just to get rid of the smoke. Obviously when it hits 55, that's your alarm condition, and normally our device would send a command to switch on the detector LED. So you can see the LEDs shining there. You can switch it off again when our detector goes into alarm. And you've also got the XP95IS manual call point. They're usually in a weatherproof housing for the addressable circuit. A lot of hazardous areas need much more robust products, so thus you've got the IS weatherproof housing used on this system. So if we look at our call point, we move up to the call point. It's analog value 16, as call points usually are. We can activate it by using the mechanism, and you get interrupts, and you get an analog value of 64 back at your main control panel. And obviously you can reset the call point in the usual way. And obviously we can send a command to switch on the LED if we so need to, which is there. Oops. Okay. So so that's our XP95IS circuit.